Let's start with our discussion of distance and displacement. Distance is a scalar variable, which means that it has a magnitude and a unit, but no direction. The symbol that we use to illustrate linear distance, and by linear I mean we're talking about the distance within a coordinate system with an x and a y, is L. And the reason for that, or one good way to remember it, is that the definition of distance is the length of the path traveled from start to finish. So let's say our biker here starts from his home and tries to head to the factory. Since there's mountains in the way, he has to take the road. The length of the path he travels is 200 meters. It's the actual, like every single step he took all the way up to the factory. Displacement, on the other hand, needs a magnitude, has a unit, but also needs a direction. The symbol for linear displacement is d, which is easy to remember because displacement starts with d. But the definition is the straight arrow from start to finish, which means if you were to open your eyes when he leaves his home and you see where he is, and then you close your eyes, he does his little path, 200 meters, his distance, ends up at the factory, and then you open your eyes again, you would really just know where he ended up and where he started. So linear displacement is sort of as the crow flies, just where did you end up minus where did you start. It's a vector variable because you can tell us which direction it was in. With distance, you're always changing direction, so the direction isn't really relevant. But with displacement, since it's just one line connected by the end position and the initial position, it's easier to provide a direction, which, if this was north and this was east, it looks like it's roughly 45 degrees north of east. The mathematical equation we use is this. D, for linear displacement, equals. This triangle here is a Greek letter that represents change in position. So when you see the triangle, it means displacement equals change in position. Change in something is usually taking its final minus the initial. So you take the position at the factory minus the position at the house, and you end up with the displacement of this person on his bike. Here's another example of distance versus displacement. If you want to know the distance between A and B, well, it depends which way you take. You can take this way, you can take this way. If you have to measure every single step that you take, that's the distance. You can't provide me with a direction because the direction constantly changes. But displacement is the shortest line between the end position and the initial position. And because it's just one straight line, you can provide me with a direction, making it suitable for a vector variable. This guy Tim going to school, well, if he had to walk 4 meters to the east and 3 meters north, his distance would be 7 meters because you're adding the whole length of the path traveled. But the displacement, since this is a right angle triangle, might be the hypotenuse of this triangle. We'll get to trigonometry a little bit later on. Again, distance has no direction because it constantly changes, whereas displacement you can provide me with, again, roughly 45 degrees north of east. Change in position is a vector. You have to illustrate a direction. So if you have frame 1 here, you took a picture, then frame 2, you took a second picture. Frame 2 represents your final position, and frame 1 represents your initial position. We place these images within a coordinate system where the origin doesn't change, and we can determine what the position at frame 1 and at frame 2 is by providing us with the coordinates, the x and the y for the center of mass here, and the x and the y for the center of mass here. I'm pointing at 2 first because this represents your final position and this represents your initial. So if you want to represent the displacement, the x, for example, you could take 9.1 minus 1.7. That represents your change in the x. It'll be positive because you're moving to the right, whereas in the y, it'll be negative because you're moving downwards. If you wanted to graph the change in position, well, you would again need 2 axes, the x and the y. On the x-axis, we typically illustrate the independent variable. That means a variable that wouldn't change, it's not dependent on anything, and in our case, it's typically time or the frame number if that's how we want to illustrate our videos. Position, this should say position would then be on the y-axis, and then you could illustrate. So at time 1, you could displace the position at 1 meter. At time 0, you'll put the position at 1 meter. At time 1, you put the position at 8 meters. At time 2, at 15. At time 3, at 21. I typically get the class to graph this table of data in class, so I don't have the graph actually completed, unfortunately.